Hello everyone, welcome to doElectronics-doEmbedded. This project is about controlling LEDs using NIOSII Processor by taking inputs from the switches. We have 3 switches and 3 LEDs on board that we'll be using for this project, and each LED is connected to its respective switch. For this project we are using Altera DE2 board, which has a Cyclone 2 FPGA and a Quartus 13.0 Service Pack 1 version. I will recommend to go through the given link for the Hello World using NIOSII project before starting with this one. That project will help you to learn how to create the project, how to create a QC system using NIOSII processor, because we will not be using those basic steps in this project. Let's start with the project. This is our Quartus project. We have a Cyclone 2 device selected as our target device, and we have a QC system already built with us. It has a clock source, it has a NIOSII processor, it has some on-chip memory, a PIO IP for LED which is 3 bits wide. I'll show you the configuration. So this is 3 bits wide configured as output. Similarly, we have a PIO IP for switches which is again 3 bits wide and configured as input. The NIOSII version we are using in this project is economical, and the reset and exception vector has been targeted to the on-chip memory. This system is already generated. As this is a DE2 board, we have pin assignments for that. So in all we have 1 pin for clock, which will be input for our system, 3 input pins for the switches, and 3 output pins for the LEDs. This is all pin assignments that is required for our project. Let's go to a software application. So we have a NIOSII application which will be controlling the LEDs. So this is a C code for that. So we have a switch value register that stores the value of the switches. This command reads the switch values, and we are ending with 7 because we are just bothered about the least 3 bits, the LSBs, which contributes to the 3 switches. So if all the 3 switches are 0, we are giving 0 to the LEDs. This command is to write to this particular address, and this address, the switch underscore base and LED underscore base, are defined in the system.h file. So you can always look at system.h file. Let's look for LED. So you have LED base preprocessor defined here. Similarly, you have a switches base preprocessor defined here. So we are using those preprocessor, also called as macros, here directly to address the LEDs and switches. So this is a small application which is built into the while loop. So every time we change the switch, that will be reflected onto the output LEDs. Let's run this project. We'll first build it. By the time we load the .sof, so this is the .sof file. Okay, so the SOF is loaded. Project is successfully built. Now I'll just run as NIOSII hardware. Okay, so the ELF file is loaded. ELF file is basically the executable file that is loaded into the NIOSII processor. So now as you can see, I am just putting the LSB switch, that is the switch 0 to 1, and you can see it is reflected into this particular LED. I am putting switch 2, that is the second number switch from LSB to 1, and now the third. Similarly, I am putting the most LSB switch to 0, the next switch to 0, and again the next switch to 0. Thank you everyone for having a look at these videos. Hope this will help you to get started with your projects using Altera FPGAs. Please follow us on the below links for more upcoming projects and interesting videos. Thanks a lot.